We'll be talking about data to AI. There have been a lot of topics and discussions since morning, and I know you're all like so much learned and so much informed in just a lot of information overdose in one day. So let's keep it a little fun, is what I'm going to say, but it's up to you to decide whether it's going to be fun or not. So I'm going to give you a dialogue from a movie, and if you know, just raise your hand up, okay? The problem we are trying to solve is that there are rich teams, there are poor teams, there's 50 feet of crap, and then there's us. Yeah? Moneyball, yes, right. So if you haven't watched the movie, at least watch it for the analytics. If not, watch it for Brad Pitt. It's a great movie. And the reason I brought it up today is Major League Basketball, I'm so sorry, Major League Baseball, it's not basketball. Major League Baseball is one of our, I can say it because they have publicly issued a lot of articles and a lot of success stories, customer stories about it. One of our very profound customers of Google Cloud. And the reason I'm talking about Moneyball is that in that movie, if you watch it, they'll show how they use analytics and data in actually making decisions about team formations in baseball for that particular state that they'll be showing in that movie. And besides that, what you should know is in just one season, they generate about 25 terabytes of data, which is like so huge for them to control with regular systems that on-prem systems and regular relational databases on-prem that they have been managing fully manually. So this has been a problem for them, but they are the teams. The Major League Baseball is one organization who have been using statistics and data science and machine learning, not really machine learning those days, even before technology has advanced so much in that field, which means they have been doing math and statistics and with pen and paper even before all these algorithms, all these machine learning models have evolved, which are AutoML models and all these things. All the angry fans around the country, in the US, of course, it's about baseball, and they have to make everything available about the players, about the teams and all that at the tip of the fingers of the people who are actually looking for information. And in order for that to be available, Google Cloud has helped them with all the infrastructure, particularly in the field of data, bringing data to machine learning or bringing data to artificial intelligence. Moving on, here is a puzzle for you. It's an easy one, the clue's in the picture. But I'm very sure you're all aware of these two players. After losing 3 matches in a row against Boris Becker, Andre Agassi went on to win the next 9 of the 11 matches. I mean, of course, the clue here is data and pattern observation, but the clues in this picture, anyone wants to take a dig at what it is? How did Andre Agassi do that? What is it that he observed about Boris Becker that led him to win the next 9 of the 11 matches? The clues in the picture. Or if you were in the CCD last year, you would have the tongue out. Yeah, exactly. That's right. So what did Boris Becker do was that, Boris Becker had this thing of when he was playing, he had his tongue out. Like if he is doing that right corner, the serve from the right corner, he had the tongue to the right side of his mouth. And when he's doing it out to the left, he had the tongue to the left of his mouth. And that's something he did involuntarily. He did not know that. And what did Andre Agassi do? He was a person who was driven by observation, data. He is a man who believes that I have to win, and how do I do that? Let me watch the videotape of all the matches that he has ever played. And he continuously kept looking at it, and what he observed was something phenomenal that he cannot reveal, and he cannot even, in one of his interviews, Andre Agassi actually went on to say that the most difficult part was not to use that information and win against Becker because he learned the trick. But the most difficult part was to hide the fact that he knows the trick, right? Because they are intelligent people. Obviously, he's going to understand that he has a trick. So he has to use this trump card very, very wisely in peak moments of the game where he can actually put that to good use or winning use. So that's exactly what it is. So you can't really problem solve unless you have the empathy or the ability to see all that's around you. So it's not just about how to do it, because technology has evolved so much that you don't need to even write a single line of code. There is AutoML these days. Like, you don't need to know what model is even going on behind the scenes. You can just point and click and drag and drop and get the app ready for your machine learning or for your AI. But what is important is, are you presenting the right information for such a machine or for such a system to make the right decisions, to enable whatever you expect from it the best possible way? So that is where the ability of observation or the empathy to the surrounding and the ethical AI and all those things come into play. And one of the things that we've been seeing through all the sessions today is that data and the unstructured nature of data in itself. So we have structured data still. It has its own power. I'm not going to say no. But definitely there is data in other formats like images, text, sound, video, and files. There is so much that most organizations are not able to be entirely data-driven, even though there is so much value and data out there that they can actually transform into impactful insights, right? Impactful analytics. Why? Because the data is so much unstructured. And any idea why unstructured data is difficult for people to, or for organizations or startups to collect and integrate, just like regular systems? Any guess? Or any pain point from your own stories? Industries or startups, or developers, you would know. The main pain point is that data live in silos, right? And you have to make multiple copies, you have to have integrations, and data is huge. You need to store them. Now, what are you going to do for all that? What kind of tools you're going to do, going to use in order to enable such an infrastructure? And what are the security risks involved in accessing some amount of data that is made available to you? And what are the local regulatory requirements that you need to meet? What are the privacy guidelines? So, and even after everything is observed, even after you take care of all these above mentioned things, the last point is, how are you going to productionize it? Ultimately, the point is anyone can write a code in their computer and say, it's done, I've solved it. But how are you going to make an application out of it and let it run with or without you, the person who developed it? It has to be enterprise ready. It has to be production ready. So that's where MLOps comes into picture. So these days, as students or as developers, once you enter the industry, it's not just enough to know or be thoroughly prepared in one area of data these days. You have to be aware, 360-degree aware of everything, starting from, yeah, of course, the business is the most important. You need to understand the data. You need to be thorough about the data that you're working with, how you're going to use it, and you have to analyze and observe the nitty-gritties in it. Next thing, engineering. Of course, you also need to know to put the pieces together and leverage the most available and the most relevant option that's appropriate for you. The third thing is, if required, you build the models or you adopt the models that are available automatically for you. Small overview of data to ML architecture. So what you see here, right here, is two blocks, the data block and the machine learning block. Just bear with me for a couple more minutes because this is, I know, deep tech a little bit, but just focus on it from the perspective of list of steps. Like, what do you need to do with your data? The first thing is data engineering. This is where you're bringing in your data from the input sources and then preparing your data, cleansing your data, transformation and all that. The next part is storage. This is the most important part. First of all, how much money does your business have to provision the right database that is required for you? One is the right database and one is affordable database, right? So all those things come into picture. And besides that, what are the design considerations you're putting in order to choose a database that will work for your structure, format, variety, and all that? Design questions and technical questions you need to ask before choosing the database. So all that come there. And then data cataloging. Basically, it's like creating an explorer of all the objects you have in the database. The next one is analysis. This is where you understand what are the objects you use in the database, what are the features you need to use, basically eliminating the unnecessary data and exploring and understanding your data even better. Creating some preliminary insights before even performing any ML or analytics, gathering some preliminary insights using SQL or using some basic programs, one-page programs. The next one is actually model development. This is where all your ML steps come into picture, like feature engineering, model training. Model registry is where you deploy your models and make it production ready. Right? Everything is API these days, agree? So the next thing is model development. This is where model registry comes into picture, where your machine learning model gets deployed, and you have an API that can be plugged into your client application, the user interface that are faced by the client. And then you have the model evaluation. This is the part where you say how much value I'm getting from the model. Is it 100% accurate? What is my accuracy level? Do I need to retrain? Say yes or no, and all that. And ML engineering is another sub-process of model development. Here you deploy the model, perform the ML ops that we spoke about before, and then monitor the model. So all these things you need to take into account. So that's what falls under model monitoring and ML engineering. The last part, which is ultimately what all businesses care about, which is the influencing business decisions, influence customer decisions, and serve your applications and services, which is influencing your own teams. So this is where your money, this is where you need, if you want budget for your project to continue next year, then this is where you need to show value. Ultimately, you should show, okay, this is the result I've brought in, and it has cost, make this change so the system won't go down in the next 6 months. Or ask the customers to apply for this or subscribe for this model, and then we'll get like 50% return on, whatever, like 200% ROI in less than 6 months, or something like that. This is where your decisions and your ML models and ML engineering, whatever you're doing with analytics, this is where it comes into play.